Welcome to Module 205A on Service Conductor and Capacity for Single Dwelling. Within this module, we're going to be focusing on 4 different objectives. These 4 objectives are going to be covered over 3 different videos. The first video is going to deal with specific terms that we use whenever we're talking about sizing a residential service, as well as different terms that you're going to see in Section 8 of the Codebook. Within the second video, we're going to move on to figuring out what actually goes into calculating how much current a single family house really needs, depending on what kind of loads are found inside their house, as well as the size of the house. And we're going to use that information to figure out what the minimum ampacity of our service conductors need to be. The third and final video is taking that conductor size and figuring out what kind of conduit do we need for our single family conductors. We're going to start by looking at the terminology as it relates to our services. Most of these terms can be used for either a commercial service like you see on the screen or for a residential service, which is what we're going to talk about. The first terminology that we need to know is what is a supply service. The supply service is owned by the utility company and it comes from the transformer up to the point of connection at our building. We don't have anything to do with the supply service. It's not our job. We are not allowed to touch it, but we should know what it is and where it ends up. After the supply service comes the consumer service. This is everything from where the supply service attaches to the building, down through the mast, into the service box. All that is considered to be the consumer service. On a residential service that has a hot metering system, we would have the meter base also included within the consumer service. The service box is the point of our service which we have the very first disconnect as well as the very first overcurrent device. On the screen in a commercial service, we would have something like a fusible disconnect. So this disconnect switch will have fuses inside it in order to facilitate our overcurrent needs. On our residential services, our main breaker coming into the house serves as both the overcurrent device as well as your disconnect switch. The next thing we need to know is what is a feeder. A feeder is all the conductors coming from the service box all the way through to our final breaker boxes, so our final overcurrent protection devices. In a commercial service, our feeders are all the conductors that come from our service box through our meter CT cabinet into our splitter and all the way up through until we finally get up to the final panels, whether that is in an apartment suite or in another commercial building that has multiple bays. Lastly, we have our branch circuits. Our branch circuits are all the conductors and everything else that is from the final overcurrent device, so our breaker, all the way to the last point of utilization. So if you think about the circuits that you have in your house, your branch circuit would be any group of devices that are all controlled by the same overcurrent device or the same breaker. Your fridge, for example, is on its own separate branch circuit from everything else in your house, whereas your bedroom would be all on the same branch circuit. So we can have multiple devices on the same branch circuit, or we can have dedicated branch circuits depending on what the code asks us to do. Looking at a residential service, we can see all the same terminology still here. We still have the supply service, which is coming from the utility up to the point of connection. By the way, on an underground service, the supply service is coming up into the meter base itself instead of an overhead service like you see. Either way, on an overhead service, my supply service is going to come in, connect to our building. From that point where the supply service connects down to my service box, which is the top half of my combination panel, that is all my consumer service. This is going to include my raceway and my meter base and the top half of my panel. The feeders are now what the bus bars are actually doing. In a combination panel, my service box is on top, my breakers are on bottom, therefore my feeders are nothing but the bus bars that connect between the two. And then my branch circuit still comes from those overcurrent devices on the bottom half of my panel all the way out to my end utilization point, be it lights or receptacles or appliances. So those are the basic terminologies for what a service is. So let's talk about a few of the terminologies that are found in Rule 8002. First, we have the basic load. Our basic load would include anything inside our building that is going to be less than 1500 watts, as well as any general purpose circuits, such as our bedroom receptacles, our hallway lighting, hallway receptacles, our outside plugs, our garage receptacles. All those things are all considered part of the basic load. The basic load is figured out by evaluating how big your house is and how much you would normally need to have per square foot. Second thing we have is the calculated load. The calculated load is when we take our basic load as well as everything that is either a dedicated load or above 1500 watts, depending on what the codebook tells us, and we add it all up together at their specific demand loads. What a demonstrated load is historical averages of different appliances as they're used over time. So buildings can have a demonstrated load, and our appliances can have a demonstrated load. It is just taking account of what general appliances are doing over the course of time in a normal use situation. An electrical vehicle energy management system is a piece of equipment that we have in our houses in order to balance out the power draw between having an electrical vehicle charger and all the other loads inside our house. By using an EV/EMS, we are actually balancing out between our electric vehicle charger and our other loads so we don't overload our conductors. This way we can have an electric vehicle charger into a house without having to upgrade the service. So make sure you know what an EV/EMS is. And lastly, our final two terms here are demand and demand factor. A demand is how much load any appliance is going to put on its circuit at any point in time. Demand is normally rated in watts. A demand factor is a percentage showing how much should be applied to that circuit. For example, the majority of the breakers that we have in our panels have an 80% demand factor. That means they can only be loaded up to 80% of what their value actually is. So if we have a 15 amp breaker rated at 80% demand factor, that means we can only load that breaker up to 12 amps, which is 80% of 15. The same thing for a 20 amp breaker. We can only load it to 16 amps because that is 80% of the total ampacity that's allowed. When it comes to electric vehicle charging systems, there are a few other terms that are not typically found in Section 86 of the codebook, but they are found in your modules. The Infrastructure Working Council has stated that EV chargers are going to come in 3 different levels. There's level 1, which is 125 volts and 15 to 20 amps maximum, so that's just your basic receptacle that you can find in your garage. And this is the lowest level that we can possibly have for an EV charger. Level 2 is any time that we're going to exceed 125 volts or 20 amp service. So if we have a 240 volt receptacle or if we have a 30 amp receptacle, both of those conditions would signify that that is a level 2 charger. You'll get faster charging rates with a level 2 charger, but it is still considered to be a residential charging system. Level 3 is a fast charge or a commercial or public station. Interestingly enough, if you go over to the cultural center at the college, you can see a level 2 and a level 3 charger that are installed in that parking lot. Let's take a bit of a closer look at Rule 8500, which has to do with the EV/EMS systems that we already talked about. An electrical vehicle energy management system shall be permitted to monitor electrical loads to control electrical vehicle supply equipment loads. What that means is that it's going to monitor your house loads in order to control how much current is available for your car to charge. When we install an EV/EMS, we are installing it right beside the main panel. The purpose of this is to put current monitors directly on the main panel feeders, which are going to monitor how much current your house is using at any point in time. Therefore, this will control how much current is going to be available for your EV charger. Take, for example, when you get home from work. It's 5 o'clock in the evening, you pull into your garage, you plug your car in, you go inside, you start making your supper, you turn on the oven, you turn on the lights, your kids have the TV on. Your house is experiencing a heavy demand load for electricity already, just with your normal living activities. If we threw an EV charger on top of that, we could theoretically overload your circuits in your system, and we could theoretically burn out your supply wiring. The EV/EMS is in place in order to monitor how much current you're using. So as you're using your oven, your microwave, and your TVs, and whatever else you have when you get home, you'll have less available charge rate at your vehicle. As you're done cooking and you put everything away and you guys go upstairs and you get ready for the night, your demand load on your house has now gone down significantly. Therefore, the EV/EMS will allow more charge to go to your electric vehicle. Okay, so now that's all the terminology that we really need to know about before we move forward. Make sure you're going through your module and go through your code book so that you are familiar and understand what these terminologies are. So as we talk about them, you don't get lost in the conversation. When you're ready, move on to video number 2.